Hi there, and welcome back to the Profundus tutorial series. In the last tutorial, you explored the advanced options for image import. This time, we will look at the augmentation parameters available in Profundus and see how you can use them to customize your training. Data augmentation creates modified versions of your existing training images. These variations expose the model to a wider range of examples without requiring additional source data. Used carefully, augmentation can improve generalization and reduce overfitting by making the model less dependent on the exact appearance of the original dataset. Let us open the Training tab and start with Horizontal Flip. Flipping creates mirrored versions of the original images. Click Horizontal Flip to open a preview of the operation. Select Dataset Images to use an image from your own dataset, and click Reroll Image to display another image. Click Close when you're finished. The Horizontal Flip input accepts a value from 0 to 100. This value controls how often the augmentation is applied. A higher value means that a larger percentage of training images can be flipped horizontally during training. When you change a parameter from its default value, the input field turns blue. To restore the default, click the Reset button next to the field. You can also hover over a parameter name to display additional information about the setting and its expected input values. Vertical flip works in the same way as horizontal flip, but turns the image upside down instead of mirroring it from left to right. Click Vertical Flip to open the preview and see the effect on an example image before deciding whether it is appropriate for your dataset. More augmentation does not automatically produce better training results. Keep each transformation realistic for the data you expect in practice. For example, a horizontal flip may be unsuitable for annotations containing text. Change only a few settings at a time, compare validation results, and use the preview to identify unrealistic transformations before training. Profundus also provides augmentation parameters that vary the colors of your training images. These settings can help the model become less sensitive to color differences caused by factors such as changing lighting conditions, different cameras, or variations in the appearance of materials. Hue jitter shifts the hue channel of an image. Click the parameter name to open the preview, then use the slider to see how different values affect the image. This makes it easier to judge whether the selected range still produces realistic examples for your training data. The other color augmentations include saturation jitter and value jitter. Saturation jitter increases or reduces color intensity, while value jitter changes image brightness. Together with hue jitter, these transformations can make the model more robust to natural color variation across different environments and image sources. For hue, saturation, and value jitter, the input controls the maximum amount of variation. Hue is randomly shifted, while saturation and brightness are randomly scaled within the specified range. In simple terms, increasing these values allows stronger color changes to appear in the augmented training images. BGR channel swap exchanges the red and blue channels. As a result, red objects appear blue and blue objects appear red. This can prepare a model for image sources where color channels may be arranged differently. A higher probability means that the channel swap will be applied more often. Invert colors replaces the original colors with their opposites. This can be useful when the same visual feature may appear with reversed colors or contrast, such as a dark object on a light background or a light object on a dark background. Higher values cause more training images to be inverted. Rotation, translation, scale, shear, and perspective control random spatial transformations. These augmentations change the position, orientation, size, or viewing angle of the image. Used appropriately, they can help the model recognize objects even when their spatial appearance differs from the examples in the original dataset. Rotation turns the image around its center. The value you enter controls the maximum rotation angle that may be applied. Choose a range that reflects realistic object orientations in your application, rather than introducing rotations that would never occur in the real data. Translation shifts an image horizontally or vertically. The input value controls the maximum movement relative to the image width or height. This can help the model recognize an object even when it appears in a different part of the image than it usually does in the training dataset. Scale gain randomly zooms the image in or out. The input controls the maximum amount of zoom that can be applied. This augmentation helps introduce size variation, which can be useful when the same type of object may appear closer to or farther away from the camera. Shear introduces a diagonal skew into the image. Higher values create a stronger distortion. As with the other augmentation parameters, use a value that still represents a plausible appearance of your real-world data. Excessive shear can create unrealistic examples that may reduce training quality. Perspective simulates a change in viewing angle. Increasing the input value increases the maximum strength of the perspective transformation. This can help when objects are observed from different angles, but the effect should still remain consistent with the viewpoints that may occur in your actual application. Together, these spatial transformations help the model recognize objects despite changes in position, orientation, size, or viewing angle. The goal is not to create as much variation as possible, but to introduce realistic variation that reflects the conditions the model may encounter after deployment. Random crop lets the model train on partial views of an image. This can improve recognition when objects are partly visible or positioned close to image edges. The input value controls the probability that a training image will be randomly cropped during augmentation. Mosaic combines content from different images into a single training image. This can help the model recognize objects in different surroundings and at different sizes or locations. A higher percentage in the input field means that mosaic augmentation will be applied to a larger portion of the training data. Use moderate values for random crop and mosaic. Both techniques can be useful, but aggressive settings may create training images that no longer resemble realistic scenes. Check the preview and consider whether the generated examples still represent situations that the model could reasonably encounter. MixUp blends two training images together. The probability parameter controls how often blending is applied. The alpha setting controls how evenly the two images are mixed. Lower values usually make one image more dominant, while higher values tend to create a more balanced blend between both images. MixUp can help the model recognize objects when other visual information overlaps with them. One example is an object viewed through a window with a visible reflection. By training on blended content, the model can become more robust when the target object is not visually isolated from its surroundings. CutMix also combines information from two images, but by inserting a region from one image into another. The probability value controls how often this happens. The alpha value controls the amount of mixing. This can help the model recognize objects when they are partly covered or surrounded by distracting visual content. Bounding box swap and bounding box pair swap move annotated objects to different positions. This helps the model recognize objects without relying too strongly on their usual location or surroundings. Bounding box swap moves one annotated object, while bounding box pair swap exchanges the positions of two annotated object regions. The probability setting controls how often objects or object pairs are swapped. Maximum attempts specifies how many placement attempts Profundus can make when trying to create a valid swap. These settings let you control both how frequently the augmentation occurs and how much effort is used to find suitable placements. For bounding box pair swap, max size ratio limits how different the two bounding boxes may be. A value of 1 requires boxes to be approximately the same size. A value of 2 allows one box to be roughly twice the size of the other. Higher values permit larger differences between paired boxes. Limiting the size difference helps prevent unrealistic swaps between very small and very large objects. This is especially useful when object scale is related to the scene structure. Keeping swapped regions reasonably similar can produce more natural augmented images and reduce the chance of introducing misleading training examples. Enable avoid box overlap to prevent moved objects from covering existing annotated objects. This can help keep the resulting training image easier to interpret and reduce unrealistic combinations where one inserted object unintentionally hides another important object in the scene. Enable prefer similar box sizes to prioritize object pairs with similarly sized bounding boxes. This can help create more natural-looking swaps because objects with comparable dimensions are less likely to produce extreme changes in scale when their positions are exchanged. Enable different classes only if you want bounding box pairs to contain objects from different classes. Leave this option unchecked if objects from the same class may also be paired. Choose the setting based on the type of variation that makes sense for your dataset and training objective. Finally, the parameters under orthogonal rotation randomly rotate images by right angles. This helps the model recognize objects when they appear in different directions, while avoiding the stretched or tilted appearance that can result from arbitrary angle transformations. The probability value controls how often orthogonal rotation is applied. A value of 0% disables the augmentation. At 100%, Profundus selects one of the permitted rotation angles for every training image processed by this augmentation. Use the checkboxes to select which rotation angles are permitted. 0 degrees allows the image to remain unchanged. 90 degrees permits a quarter turn clockwise. 180 degrees permits an upside-down rotation, and 270 degrees permits a quarter turn counterclockwise. You now know the augmentation parameters available in Profundus. Before applying an augmentation, consider why it is useful for your dataset. Use the preview to compare original and augmented images and bounding boxes, and remember that you can preview either example images or images from your own dataset. Good luck with your project, and see you next time.